This is Mr. Beck Does Your Homework, question number 6. Similar to the last problem, we're going to be calculating the angular momentum of a single object that's moving in a straight line. So this says the airplane of mass 998 kilograms flies level to the ground at a constant speed of 175 meters per second relative to the Earth. An observer on the ground along the path of the plane sees the plane a distance 12,885.8 meters away at an angle above the horizontal of 58.611 degrees. What is the magnitude of the airplane's angular momentum relative to a ground observer directly below the airplane? So if we were to draw this picture, we would see that someone over here is looking up at an airplane that's located over here. We know that this distance here that I'm given is going to be actually this distance here. It's going to be the hypotenuse, and I tell you that in the problem. The distance to the plane is the hypotenuse. Since this is on the ground, what we're looking for is there's going to be another observer right here below the plane, and we want to know the angular momentum relative to that person. So we're given this angle, we're given this distance, so that's going to be an r, and this is a theta, and I want the angular momentum. We're also given a velocity here of the plane, and we're given the mass of the plane. So as we learned in the previous problem, and as we'll see in this problem, this r times the sine of theta is going to give me this distance here, and that is what's really necessary to calculate the angular momentum of the plane around that point. So angular momentum of a particle is simply going to be mvr, where r is going to be the perpendicular distance here, as opposed to this r. If you want to use this r, then your angular momentum would be mvr sine theta, but sine theta is merely going to give you, again, r sine theta is going to give you this, so r sine theta will give you the vertical distance there.